Units. Physics describes the laws of nature. This description is quantitative and involves measurement and comparison of physical quantities. To measure a physical quantity, we need some standard unit of that quantity. An elephant is heavier than a goat, but exactly how many times? This question can be easily answered if we have chosen a standard mass, calling it a unit mass. If the elephant is 200 times the unit mass and the goat is 20 times, we know that the elephant is 10 times heavier than the goat. If I have the knowledge of the unit length and someone says that Gandhi Maidan is 5 times the unit length from here, I will have the idea whether I should walk down to Gandhi Maidan or I should ride a rickshaw or I should go by a bus. Thus, the physical quantities are quantitatively expressed in terms of a unit of that quantity. The measurement of the quantity is mentioned in two parts. The first part gives how many times of the standard unit, and the second part gives the name of the unit. Thus, suppose I have to study for 2 hours. The numeric part 2 says that it is 2 times of the unit of time, and the second part hour says that the unit chosen here is an hour. But who decides the units? How is a standard unit chosen for a physical quantity? The first thing is that it should have international acceptance. Otherwise, everyone will choose his or her own unit for the quantity, and it will be difficult to communicate freely among the persons distributed over the world. A body named Conference General des Poids et Mesures or CGPM, also known as General Conference on Weight and Measures in English, has been given the authority to decide the units by international agreement. It holds its meetings and any changes in standard units are communicated through the publications of the conference. Fundamental and derived quantities. There are a large number of physical quantities which are measured, and every quantity needs a definition of unit. However, not all the quantities are independent of each other. As a simple example, if a unit of length is defined, a unit of area is automatically obtained. If we make a square with its length equal to its breadth equal to the unit length, its area can be called the unit area. All areas can then be compared to the standard unit of area. Similarly, if a unit of length and a unit of time interval are defined, a unit of speed is automatically obtained. If a particle covers a unit length in unit time interval, we say that it has a unit speed. We can define a set of fundamental quantities as follows. First, the fundamental quantities should be independent of each other, and second, all other quantities may be expressed in terms of the fundamental quantities. It turns out that the number of fundamental quantities is only 7. All the rest may be derived from these quantities by multiplication and division. Many different choices can be made for the fundamental quantities. For example, one take speed and time as fundamental quantities. Length is then a derived quantity. If something travels at unit speed, the distance it covers in unit time interval will be called a unit distance. One may also take length and time interval as the fundamental quantities, and then speed will be a derived quantity. Several systems are in use over the world, and in each system, the fundamental quantities are selected in a particular way. The unit defined for the fundamental quantities are called fundamental units, and those obtained for the derived quantities are called the derived units. Fundamental quantities are also called base quantities. SI units. In 1971, CGPM held its meeting and decided a system of units which is known as the International System of Units. It is abbreviated as SI from the French name Le Système International des Unités. This system is widely used throughout the world. I'll come up with another topic in the next video. Until then, bye bye.